Friends, welcome to this session on probability and inferential statistics. As far as data analytics is concerned, this theme is a pivotal one. In order to interpret what data says, in order to provide the meaning to the content of data, probability as a concept helps. And then, based on probability, inferential statistics can be computed. That also provides meaning to the data. In our presentation, we are going to discuss the insights from Fisher's book on statistical uh, methods. It's titled Statistical Methods for Research Workers. It's an interesting book. So our ideas in this slide owe greatly to that book. What is statistics? Oh, that's a clueless question. What is statistics? But then, one way of approaching what is statistics is from three viewpoints. Three aspects could be looked at to understand the meaning of statistics. It consists of three fundamental constituents. It includes study of populations, study of variation, methods of production of data. Before coming to these aspects, it's also important to understand two dimensions which would throw light on nature of statistics. Two dimensions. One dimension is variation. In this slide, look at the vertical part, variation. And on horizontal dimension, it's classes. So variation is of two types, discontinuous and continuous. While in the case of classes, again it's classified into two, finite and infinite. Now we juxtapose variation with classes. What we get from this juxtaposition? Variation, with respect to variation, look at the dimension discontinuous. And it can be clubbed with classes. So combinations like finite and discontinuous, discontinuous variation and finite classes is something like your measurement is discontinuous in nature. For example, you code a phenomenon and you code another phenomenon, but then it's not amenable for any arithmetical operations. Classic case is gender, or something like whether you like coffee or not. Yes, no. So yes is coded 1, no is coded 0. What is in between? We don't know. There's no query regarding what is between. So that's why it's called discontinuous. Here we have given gender as an example. So there's no continuity. Each code is discrete. There's discreteness between these two. Now another important uh, combination is discontinuous and infinite. A good example is number of children. So we don't express number of children in decimals, right? That's what makes this example discontinuous in terms of variation. Whereas in the case of classes, there can be numerous children, right? Number of children. Numerous can be numbered, so it's not really speaking finite. It's more closer to uh, infinite. Now the third category is continuous and infinite. A good case is height. There could be many heights possible, and it's continuous. It can be expressed in fractions. For example, 6 feet, 6.1 feet, 6.2. That's a classic case.